Hello, this is Dr. Mears, and today we are going to learn about optimization. Optimization can help us find minimum and maximum values. Examples. Number 1, a box is made up of a piece of rectangular cardboard that measures 6 centimeters by 9 centimeters with squares of sides x centimeters cut out of the corners. The formula for the volume can be modeled by V equals 4x cubed minus 30x squared plus 54x. Plot the graph and find the maximum value. So what we're going to do here is use our TI-84 and we are going to plot the graph. So I'm going to turn it on. Now, if you want to learn how to plot graphs, I have other videos for that. So I'm just going to run through this rather quickly and press the Y equals button. As you can see, I have my equation in. Please be careful. You do have a cube here. And so just remember the exponent button is right here above your division symbol. Okay, so I have my equation in, and then what we're going to do is press zoom, and if we standardize it, that means that we're going to be going by a 10 to negative 10 grid, and as you can see, we can't see the whole graph. Now, we're looking for a maximum value here. So this graph looks a little bit different. We've been dealing with quadratics. This is a cubic, hence the 3 is the highest exponent. And so it looks a little different. This is a minimum value down here. Do we want that? No, we want the maximum value. And I'm thinking the maximum value happens somewhere up here. So what I'm going to do is I'm going to press the right arrow key and I'm going to see my little blinking dot. And I'm just going to go up to where I'm going to want to zoom out. So I'm going to go all the way up. So my blinking dot is at the top of the screen because I want to see where this picture is. And I'm going to press zoom and then 3 for zoom out and then enter. There we go. So here we see my maximum and here we have a minimum. And so what does the problem ask for? The problem asks for my maximum. So what we're going to do is focus on this maximum point right here. And we're going to find that by pressing second trace. And when we press second trace, we see that we have number 4, which is maximum. And we're going to press number 4. And on the bottom, you're going to see left bound. That means that you have to go to the left of that maximum point. So that's absolutely fine. You could go there. You could even go a little bit below it. Right here, that's fine. But just if you look at my pencil, we're looking for that point right here. We have to go to the left of my pencil tip, and the blinking dot is on the left. So I'm going to press enter. Now, if you notice, it says right, so I'm going to move my blinking dot to the right side of this maximum point, which is the right side of my pencil tip right here, and I'm going to press enter. And it asks us to take a guess, and I'm going to press enter again. And as you can see, the maximum is at 1.177. So I'm going to actually do 3 significant figures and 2.58. So let's write that down. 1.18, comma 28.5. Okay. So I actually have a nice graph here for you. I blew up the picture a little bit so that you could see where this point was. So here we had a minimum. We didn't want that. We wanted maximum. So then we located this point. This point is the maximum. Then on the calculator, after we graphed this, we pressed Y equals, and then we put the equation in. Then we press second trace, and we press number 4. I believe it's number 4. Yes. Yep, for maximum. And then we did the left and the right, and we took a guess. And we pressed enter through all of those. So those are some quick tips in case you forget. And we found this point right here as 1.18, comma 28.5. And so we have to figure out, it says find the maximum volume. Which one of these is the actual volume? So let's look. We have a box made up of rectangular cardboard. The sides are x centimeters long. So this is the side length. Okay, that's the x. The x is the side length. And the formula for the volume can be modeled by V equals. So this is the volume because it's the y. So when we answer the question, find the maximum volume, we want the 28.5. So we want the 28.5 because that is what they say the volume is. So maximum volume is 28.5 centimeters cubed. And the reason why it's cubed is because volume has 3 dimensions, length, width, and height. And in our formula, we have a cube, so it's centimeters cubed. And this is how you would write the problem. Please be careful, because if you don't say centimeters cubed, if you just said 28.5, you will get points taken off. You do have to know that volume is in centimeters cubed. Okay, let's go to the second one. We're going to do it just like we did the first one. Okay, let's read it first. And I did, as you could sneakily see, I did include the graph, but let's graph it on our own, and then we can look at the one that I provided. So Teddy owns a cake shop. On a single day, the profit in US dollars that Teddy makes is dependent on the number of cupcakes he bakes. The profit can be modeled by the function P of C equals negative 0.056C squared plus 5.6C minus 20. Find Teddy's daily maximum profit and the number of cupcakes he needs to bake. So first, before I do anything, we are going to get an XY point. You know what? Let's label what X and Y are here. So here they say that C is the number of cupcakes. So X is number of cupcakes, comma. Okay, what is that Y, or in this case, P of C? This is his profit. So I like doing this because when I get that point in my calculator, I can just look at my little key here and see, well, they want the maximum profit, so I'm looking for this value, this second value. So if this helps you to line it up with these word problems, please do this. It's a good strategy to use. Okay, so let's press in our calculator Y equals, and we are going to be clearing out, and we're going to be entering negative 0.056 x squared. Now, I know there's a C. That's fine. You can still use this X button right here. Just change it over to X plus 5.6x minus 20. Double checking it. Perfect. Now, let's press zoom 6 because this is just going to get our standard graph. And again, we're probably going to have to zoom out. There we go. You'll notice it is quadratic because the highest exponent is 2, and it looks like the maximum is going to be somewhere over here. So what I'm going to do is get my blinky dot on it. I'm going to go all the way up to where I want to zoom out. So my blinking dot's all the way up here, and I'm going to zoom, and I'm going to press 3 again. And notice it says zoom out. It hasn't done anything. If you see these words, zoom out, you need to press enter again. So pressing enter. And you know what? Looks like we're just going to have to do that one more time. So I'm going to move my blinky dot to where I want to zoom out, and that's all the way up here. Zoom 3, enter. Ooh, and look at that nice graph. And so where do we want to find? It says maximum profit. So we want to find our maximum up here. So we're going to go back, and just like we did here, we're going to start here. We're going to do second trace, and we're going to run through all of those steps. So second trace, we're going to go down to number 4 for maximum. Left bound, oh, look at that. It's already on the left side. So we're trying to find this maximum point up here. And so we want to be on the left side of this maximum point, and we are, so press enter. Now we have to press the right arrow key to get to the right side. So this is the right side of my maximum point. Press enter and take a guess. And here's our maximum. I'm actually going to round that to 50 because if you notice, for 49.9, that's the number of cupcakes. We're not going to have 0.9 of a cupcake. So I am going to round that to 50, and then the Y is 120. So on this graph, I'm going to put a little point here. I did graph it for you in Desmos, yay. And I'm going to do 50, 120. Okay. So what do we need? First, we need daily maximum profit. So if we go over here, 50, 120, 50, number of cupcakes, profit, 120. See how this all lines up? Again, if you like this, use it. All right, so daily maximum profit is $120 US. And how many cupcakes? And we need to find the number of cupcakes he needs to bake. So as you can see right here, number of cupcakes that, there's my lights. Number of cupcakes that he needs to bake is 50. He needs to bake 50 cupcakes to make his maximum profit. So there you go. So we optimize these problems, meaning we found the maximum value. Sometimes you might find a minimum value. So just be careful for what it's looking. These two problems, they were of maximum profit. We were maximizing, which is absolutely fine. If it was looking for a minimum, you'd probably be looking for something like this here if you're looking for a minimum. So you just have to make sure that you're reading the problem correctly and you're finding the correct point. And then you're also finding which number you're going to use. And a helpful way to do that is making a little chart for yourself. This has been optimization. I hope it helped.